Hello. In this video, I'd like to share with you how to graph quadratic functions written in standard form. A parabola is the graph of a quadratic function, which looks like a U shape that has tails that point up or down. When the equation of a quadratic function is written in this form, f of x equals a times x squared plus bx plus c, we call that standard form. A, B, and C represent real numbers. The highest point of the parabola, if the tails point down, or the lowest point if the tails point up, is called the vertex. Fortunately, the vertex can be identified with small calculations when the equation is written in standard form. The x-coordinate of the vertex is found by using the a value and b value coefficients. X equals the opposite of b divided by 2a, and with the x-coordinate found, one can calculate the y-coordinate by substituting back into the function. Identifying the maximum or minimum of a quadratic is easy to do if you look at the a value of the quadratic equation in standard form. When the a value is positive, the vertex is at a minimum, and the tails open up. When the a value is negative, the vertex is at a maximum point, and the tails open down. When graphing a quadratic function in standard form, we may select coordinates for x and compute f of x to compute a table of values that could be plotted in a coordinate grid. But this would require a bit of luck or careful calculations to determine appropriate x values for our table. Instead, I recommend identifying the vertex to rewrite the quadratic function in vertex form, and using the a value to determine the position of the remaining key data points of the parent graph. Here are a few examples. Example 1, f of x equals 2x squared minus 12x plus 15. First, we need to calculate the x value of the vertex. Since x is equal to the opposite of b divided by 2a, we would have the opposite of negative 12 divided by 2 times 2. When simplified, we find that x is equal to 3. We then substitute this value into the original function to calculate the y-coordinate. With a little bit of simplifying, we see that the y-coordinate is negative 3. With the vertex identified, 3, negative 3, we then use the a value, 2, to determine the location of the remaining key data points. We step to the left and right of the vertex 1 unit and up 2 units. Then we step left or right 2 units from the vertex and up 8 units. Remember, each of these vertical steps are twice the height of the original parent function because the a value is 2. Finally, connect these points with a smooth and continuous line with arrows that point up. Example 2. F of x equals negative x squared minus 4x minus 5. Please pause the video and try this example on your own. Resume playback in a moment to check your work. The vertex was computed as -2, -1, and the a value was -1. So the parabola opened down and was the same size of the parent graph. Example 3. F of x equals 1/2 x squared plus 2x minus 1. Please pause the video again and try this example on your own. Resume playback in a moment to check your work. The vertex calculated to be -2, -3, and the a value was 1/2. This forced the parabola to open upward with the height of each coordinate half that of the parent function. Hope these videos help you understand the graphing process for quadratics. Good luck on your next examples.